Hi, and welcome to Coding with Dennis. My name is Dennis. In this video, we'll be looking at how to create label maps for your volumetric images, so we'll not be doing any actual coding in this video. For labeling, we'll be using the open source software platform Slicer 3D. Slicer is created for medical image processing, and a great thing about Slicer is that it works both on Windows, Linux, and OS X. So essentially, this video will show you how to prepare your data for some other learning algorithm. As an example, I advise you to look at my small video series on 2D UNet, where we are segmenting teeth in CBCT images. So at first, let's fire up Slicer and let's load some data. So here we have 3D Slicer, and what we can do is just drag and drop one image to the viewer here to load an image. So now we see three different slices of this volumetric image. We can use the sliders here to slide through the volume. Then we can slide through like all different directions of this volume. If you left click in an image here and drag to the left or to the right, you can see you change like kind of the contrast of the image. And if you move up or down here, changing like the span of pixel intensity is being shown. Up here in the top, there's the modules panel. So if we choose that one and all modules, let's try out first with this Otsu threshold image filter. So maybe before applying this image filter, let's have a look at what this Otsu method actually does. So just on Wikipedia here, there is a very good illustration. So like a few examples of like an input image, like a grayscale image, and it becomes some binary image, like there's a background and a foreground. And if we have a look at this visualization down here, then we can see that there is kind of two distributions in this image, like some background here and some foreground image. And what the Otsu method is doing is trying to find an optimal way to separate these two classes. So this method is great if there's a clear pixel intensity distribution difference between the items you're interested in segmenting and some kind of background. So let's now go back to Slicer and have a look at how the method performs here. So input volume, just the forearm image, and then we create a new label mask as the output. Then we apply, let it run, and then we see now it labeled in fact the full forearm instead of usually you would only be interested in like some of the bones in the forearm. So we can go here again to modules and then data. Here we have all the data that is shown in the scene. And here with this small eye icon, you can hide or show either the images or the label masks here. Okay, so in fact here, this was not exactly what we wanted. What we wanted was to segment the bones inside this forearm instead. So let's go ahead and delete this label mask here. So here in the data overview, what we can also do is right click on the forearm image here and click edit properties. So now this will open the properties panel of the image. And here we can in fact see like this trick we did before with left clicking and moving to the left or to the right. We can kind of see what it's doing here. So it's just moving the range of pixel intensities that is kind of visible to us. And then we see a small additional panel down here, namely the histogram. And if we click that one, then we can see the histogram of the pixel intensities in this particular image. And here we see why the Otsu method might not have worked for our purpose here. Like it probably found a threshold over here somewhere. So it just had the background and then the full forearm. Whereas it should have found some threshold all the way up here at maybe around 1000. That seems like that will segment the bones nicely from all the tissue and the background. So at least this panel here is good to get an overview of the histogram, like the information of your volumetric image. So let's now head over to the segment editor. So what we'll do here is add a segmentation, and we can give it some color. Let's just say that it's the bone color. And the first thing we'll try out with is a simple threshold method. So we saw before from the histogram that 1000 seemed like to be a good lower bound to segment our bones. So we just put threshold 1000 and then click apply. And after we have our mask here applied, we can also see how this looks in 3D by clicking this show 3D icon. And over here in the 3D view, if you click this tiny button here, it would center your 3D item here. Then we can kind of expect that here we have the radius, the ulna, we have the humerus down here, and some of the bones from the hand. So an additional step I usually do is go here to the island module and then remove small islands. And here is a rather large image, so let's just remove islands with less than 100,000 pixels in it. So usually there'll be some small islands which are not that visible to us if we just inspect on this level here. And this will just make sure that all these small noisy islands are removed. If we're only interested in one of these segments here, the lastest one, there's also just keep the largest island here. We can just try to apply it. Then it'll only keep one of the bones here in the forearm. You can undo that. We can also click this one, which is split islands to segments, which would then, instead of having one segmentation here of all the bones, will split it into individual bones. So we can try to apply that. And now we see, okay, let's just change the color of the first one here to tissue. So now we see that we have a different color for each of the bones here. So now let's say we're not interested in the humerus, so we can just go ahead and, well, remove this part. It could also be that, for instance, some part of the hand up here you're not interested in. Then there is the scissor tool here, which is quite nice. Remember, you have to stand on the segmentation here that you want to clip. And then you can simply just cut away some of the items here from the hands. And here you can choose like how it should fill up the area you just clipped away. So there's a lot of different options here for the filling. Another tool I use a lot is this paint and erase. We will see that a bit later on some other images where it's even more useful. But for now, we can just imagine that we want to make some synthetic data, that there is some obstruction in the data. So we can either add or remove items to the image. Whenever we are here in the 3D view, you can hold down Shift, and then it'll kind of recenter all the other image slices here to that specific part in the 3D view. And now you see that, let's just make this diameter slightly bigger. Like we just have this tiny disc here, kind of slicing through. So this will take a long time. Like let's say if we want to remove all of this area here. So what you can do is click this spherical brush. So even though you're in a 2D slice here, then you would still remove also the neighboring from the neighboring slice. Whoops. So I wanted to add from, or erase. We could also, let's take erase first from this area here. And yeah, then we could also add, which is done exactly the same way, like this here. Another thing here you can note is this editable intensity range. So in fact, let's say that you only, like you manually want to paint where there's bone. So now we have the range only, it's only allowed to paint from pixel intensity 1000 and upwards. So if we paint out here, it would not add anything. But if we paint down here where we just removed part, we'll segment this, and also this part of the humerus which we removed before. So the only thing we need to do now is export it, and this is done here in this segmentations module. So if we click that one, then here in the button there's this export import models and label maps. So here we can just export a label map. We can export it to a new label map. Click export, and we see like it's the name segmentation label 2. We can go to file and save, and segmentation label 2 we can save as an NNI to have the same format as the input, and then save it somewhere on your local hard drive. Alternatively, you can also export the models And then either here, like here, we can just export to new model hierarchy, export. If we go to File and Save, then we'll see here we have a mesh for each, both the tissue, the bone 1, bone 3 here. So each of the 3 bones here. We have a separate mesh form. We can choose whatever format we want to save it in, and the location on disk. Okay, so this here was some of the very, very basic items you might want to use in the segment editor of Slicer 3D. Now let's move over to a slightly more advanced example instead of this simple clean CT image where it's quite nice and easy to segment the different bones. Okay, so what we have here is a CBCT image of a person. And what we immediately see is that this kind of image is way more noisy than the clean CT image that we were working with before. So the task here is in fact just to segment a single tooth. So instead of working on the full image volume here, let's just go ahead to begin with and crop out a single tooth. So again, in modules, you'll also find the cropping tool, crop volume. Remember to create a new annotation, region of interest, and also display this region of interest. Now we can then mask out the tooth that we would like to work with. Note, if you want to see this exact slice in the other views, you just hover it and hold down the Shift key. So like it seems like the roots, they are here somewhere. Okay, once we have that, go ahead and click apply. And then we have a single image here of just one tooth. So we can go here in data and we see we still have the full image volume we can also visualize, or we can just visualize the single small cropped volume. So now, without doing any pre-processing of the image, let's just go ahead to the segment editor and have a look at how this thresholding might work. So let's see if we can find a threshold here that just segments the tooth. So again, like the roots are down here somewhere. So maybe something like this here. Go ahead and apply and try to show this tooth here. If we zoom in, we see we're somehow successful, at least here on the one side, but there's still quite a lot of noise. So what one could do now is then just go over to erase and paint and, paint up all the missing area in here. Choose the spherical brush and remove all the parts that we're not interested in. This is one way, and this will be very time consuming, where you really have to go through each individual slide. So let's remove that segmentation, and let's also first see, can we do something to clean up the image a bit. So let's go on the modules and find filtering and some kind of denoising. And let's just try out this gradient and isotropic diffusion. We put in the cropped, and we just create a new volume on the out. That's the out. Click apply. At least now it's smoothened, maybe a bit too much. So we can go ahead and again create new volume output and play a bit around with these parameters until we have a satisfying result. So obviously this can easily end up taking quite some time, and there is even more filters. So here, if we go on the filters, the denoising, you can also just try with a simple Gaussian blurring, so curvature anisotropic diffusion, or the median image filter, and see what works best for you. Now under modules and data, we'll then have a lot of different images here. Just go ahead and delete all the ones we do not need. And now we'll just be working here with output volume 8. This is also the one we have shown here. So we have some kind of segmentation. We'll just delete that. and go into the segment editor. And here, I'll just have create new segmentation, and we'll be working with output volume 8. Okay, let's create a new segment. Let's see if the threshold works slightly better. So somehow at least slightly better, at least here on the edges. It looks way more smooth, but we still have these neighboring teeth being highlighted also up here. So instead of this, we will manually paint some here on this tooth, and then be using this grow from seeds. So also here, remember to click the spherical brush, and we can also set a range. So if we just hover here, we can get an idea about that on the edge here. It's probably like 450 or something. And now if we go ahead and paint here, we would only be painting what seems to be the tooth. We see down here at the roots, we still have some manual cleanup to do. And now here where we have a neighboring tooth touching, we should just be very careful not to segment that tooth as well. And you can also just turn off the range to mark everything inside here. And probably erase a bit of the mistake we did down here. Okay, so now we segmented at least some of the slices here, the tooth, and now we need to add another segment, which will then be our background. So now we can just paint. Let's just turn off this editable range, and we're just drawing outside here, outside the tooth. Especially here where the neighboring tooth is touching, is quite important to highlight that as being the background. Otherwise, it would usually just include that in the same segment as the tooth. Okay, so now we only just highlighted a few slices here. Now we can try to see how well the grow from seeds works at the current state. Click on grow from seeds, initialize, and then apply. Then we see like it grew, and definitely some places like down here, then it was just filling totally up with the tooth, which it should not have done. And if we look here in 3D, we can just remove this here. So again, some places it went okay, but the idea is now to simply go over some of the slices where it performed really bad, put whatever it did, put here in this tooth segment as the background instead, manually do that. So if we click here, shift, then we can see there's a lot here, like a lot going on here, which was highlighted as tooth, which should not be tooth. So just go ahead and click undo. Then we undo the whole process of doing the grow from seeds. Now you then go ahead again and paint in some of these slices. Oops. That here it should be the background, and that in here should, for instance, be the tooth. And let's just add the editable range there. And let's go ahead and try again. Initialize, apply. So at least now I got this slice here correct. Probably there's other places like here where there's some problems. Let's have a look at how it looks in 3D. So slowly getting there. It seems like we should have some cleanup of in between here the roots to find that where the background segment is. So I'll just go ahead and iterate over this a few times and speed up the video a bit. Okay, so as you can see, this can be a quite lengthy process to segment these teeth in such a noisy environment here. In the end, usually I tend to do some simple smoothing of just the segmentation here. So this is smooth, and then we can just try with a simple median filter first. Okay, this might be a bit over smoothing. Just have a 1 millimeter kernel instead, and try to smooth it again. So at least it's slowly starting to look like a tooth. Like, I would probably iterate over this a few more times before actually using the stable mask. But in general, these CBCT images is just so noisy that it's even for the human eye very difficult to figure out what is background and foreground. And compared to just labeling every single pixel in every slice, I definitely think that the growth from seeds speeds this process up a lot. But once the data is so noisy as it is right here, you just have to iterate and iterate and iterate, and eventually you'll get to some usable result. Again, just like in the forearm example, you can just go to segments, export, and here we can just export the label map, export, go up into file and save. And now we have our final label map down here, which we can just save to file. So this was a short introduction to volumetric image segmentation using 3D Slicer. Let me know in the comment field if you found this kind of tutorial useful. Also let me know if you have any other good segmentation tricks in Slicer, or if you're using any other open source software for your volumetric image segmentation. On a final note, remember to like the video and subscribe to the channel for more videos. I hope you learned something, and I hope to see you back in the next video. But until then, thank you for watching.